Oh, ever wondered how computers organize data? The secret lies in sorting algorithms. These are ingenious methods that help computers arrange data in a specific order, be it ascending, descending, or even categorically. They're crucial in computer science, enabling efficient data handling and speedy problem solving. We'll journey through 5 of these algorithms: bubble sort, selection sort, insertion sort, merge sort, and quick sort. Each offers a unique approach to sorting data, and we'll unpack how they work and their time complexity. Ready to dive into the world of sorting algorithms? Hang tight. First off, meet bubble sort. The simplest yet quite interesting. Imagine you're in a room full of balloons, each with a different number. Your task is to arrange them in ascending order. How do you do it? Start from one side, compare each pair of balloons, and if they're out of order, swap them. Repeat this until no more swaps are needed. That's the essence of bubble sort. Though it may not be the most efficient with a time complexity of O(n squared, it's straightforward and a good starting point for beginners. That's bubble sort for you. Simple and easy to understand, right? Next up, let's get acquainted with selection sort. This algorithm sorts an array by repeatedly finding the minimum element from the unsorted part and putting it at the beginning. It does this by maintaining 2 subarrays in a given array. The first subarray is already sorted, while the second subarray is unsorted. With each iteration, the smallest element from the unsorted subarray is picked and moved to the sorted subarray. Its time complexity is O(n squared, making it less efficient for large lists. And that's how selection sort works. Pretty neat, huh? Moving on, we have insertion sort. Picture shuffling a deck of cards. One by one, you pick a card and place it in the correct position within the already sorted portion. That's insertion sort. It's great for small data sets or nearly sorted lists with a time complexity of O(n squared in its worst case. Remember, it's not efficient for large data sets, but it's simple and stable, making it a handy tool in your coding arsenal. So that's insertion sort for you. It's like sorting a deck of cards, isn't it? Now let's talk about merge sort, a more complex but efficient method. Imagine you're shuffling a deck of cards. You split the deck into 2 halves, then keep splitting these halves until you're left with individual cards. That's the first part of merge sort, the divide phase. Next up is the conquer phase. You start merging these individual cards back into pairs, ensuring each pair is sorted. You then merge these sorted pairs into sorted quartets, and this merging continues until you have a completely sorted deck. Why is merge sort special? Its time complexity is always linear, logarithmic, meaning it's impressively efficient even for larger data sets. It's like having an army of sorting elves, each responsible for a small task, then combining their efforts to achieve the result quickly. However, it does require more space as it creates new arrays during the process. So it's a trade-off. More memory for faster results. That's merge sort, a bit more complex but highly efficient for larger data sets. Finally, meet quick sort, the fastest of them all. This algorithm is like a master of delegation. It picks one element from the array known as the pivot. Then it rearranges the array so that all elements smaller than the pivot are on its left and all larger ones are on its right. The pivot, now in its final position, splits the array into 2 halves. Quick sort then recursively applies the same process to each half until the entire array is sorted. That's the beauty of quick sort. It breaks the problem down into smaller, manageable chunks, making it a classic example of a divide and conquer algorithm. Its best case time complexity is linearithmic, or O(n log n, and it's generally faster in practice than other algorithms with the same time complexity. It's particularly effective for large data sets. And that's quick sort, quick and efficient, living up to its name.